Welcome to the AQA pre-release material for summer 2026, Ant Simulation. The objective of this animation is to talk you through how the application works. This animation uses version 2 of the pre-release code announced by AQA on the 21st of November. Please ensure that your students are using the correct version of the pre-release code. The pre-release material this year is a simulation of a small world of ants showing their interaction with a nest, food, and pheromone trails. On loading the application, the user is invited to select the simulation they would like to use. Although no details are given about the different simulations available, the user can enter options 1 to 4 to choose the simulation to test. The simulation world is a grid of cells which can contain nests, queen or worker ants, pheromones, and food. Depending on the simulation selected, the size of the grid, number of nests, number of worker ants, and aspects of the food and pheromone setup can be adjusted. The grid of cells is stored as a one-dimensional list, and during operation of the application is also shown as such. However, it represents a two-dimensional array. Simulations 1 and 2 represent a 5 by 5 grid. Simulations 3 and 4 represent a 10 by 10 grid. Details of what is contained in the grid will be explained later in this presentation. As mentioned, the grid is stored and shown on the screen during the operation of the application as a vertical one-dimensional list. Shown here are the actual index positions of the grid list for an example starting contents in Simulation 1. If, however, we rotate this to be horizontal, the relationship between the two-dimensional array becomes clearer. Since Simulation 1 represents a 5 by 5 array, each row is stored sequentially in the main grid list. Cells in the grid list at index 0 to 4 represent the first row. Cells at index 5 to 9 represent the second row, and so on. Although interaction with the simulation uses the row and column grid references, a useful technique for students is to print off a grid similar to the one shown on the screen so that they can understand how those row and column references interact with the application. Moving back to the configuration of each simulation, Simulation 1 represents a 5 by 5 grid. All the simulations are configured using a list called simulation parameters. Within the standard pre-release code, there is no option to adjust these parameters beyond manually hard-coding them. The parameter list is laid out as follows: the number of nests in the simulation, the number of rows in the grid, the number of columns in the grid, the starting amount of food in the nest, the starting amount of food cells, the starting number of ants in a nest, this includes the queen, the strength of a new pheromone when it's laid down by an ant, and the amounts that pheromones decay from one stage to the next as the simulation advances. In all 4 simulations, a default ant nest is placed at location 2-4. In Simulation 1, the single nest is created with a single queen ant object together with 4 worker ants, therefore totaling 5 ants. 3 food cells are placed into the simulation at random locations within the grid. Each food cell contains 500 units of food. When placing food cells, the code checks the nest locations so that food cannot be placed directly into a nest. It does not, however, check if food is already present in a cell. Therefore, it is perfectly possible to place 2 or even 3 food cells into the grid in the same location. The pheromone strength for Simulation 1 is set to 1,000 units with a decay rate of 50. This means that the strength of a pheromone will decay by 50 units at each stage advance, representing pheromones decaying over time in the real world. In Simulation 2, the configuration is the same, however the pheromone decay parameter is double that of Simulation 1, meaning that as the simulation advances from one stage to the next, the pheromones left by the ants will decay at twice the rate. In Simulation 3, the world grid is double the size using a 10 by 10 grid. A default single nest is still placed at location 2-4, and the simulation still uses 3 food cells placed at random locations and the default pheromone strength of 1,000. In simulation 3, however, the nest starts off with 1 queen and 8 workers, therefore totaling 9 ants, and has a pheromone decay rate of 25, which means that the pheromones decay much slower as the simulation advances from one stage to the next. Simulation 4 uses a similar configuration to Simulation 3, using a 10 by 10 grid and a pheromone decay rate of 25 units per stage advance. Simulation 4, however, includes 2 nests, each with a queen and 5 workers. The standard default nest is still placed at location 2-4, but a second nest is placed at a random location. The code checks to ensure that the new nest cannot be placed at the same location as an existing one. Once the simulation is set up, the user is then presented with the main menu for the application. This allows them to display the overall simulation world in general terms, remembering that it is shown as a one-dimensional vertical list. Option 2 shows part of the simulation world, allowing the user to enter the grid reference for the top left and bottom right cells of a viewing window. This feature is particularly useful in Simulation 3 and 4, where the user may only want to see a smaller portion of the simulation world. Option 3 allows the user to inspect a single cell. This function allows the user to drill down through the data within an individual cell, including if there is a nest in there, how much food is in the nest, how many ants are in the cell, what pheromones are in the cell, together with which ant laid those pheromones down and how strong they are. Option 4 allows the user to advance the simulation forward one stage. Each of the main entities within the simulation has an advanced stage method, which is called when this option is run. Option 5 allows the user to advance multiple stages in one go, therefore allowing the simulation to be sped up. Option 9 allows the user to quit the application. In this example, the user has selected option 4 to move the simulation forward one stage. You can see that 3 of the 4 workers have come out of the nest, but none of them have yet to find any food. The remaining part of this animation will look at the advanced stage method in the simulation class, as this is where the main aspects of the application happen. The application is essentially managed by 3 main lists: ants, pheromones, and nests. These store the 3 main entities of the application, showing their position and configuration within the overall grid list. When the user selects to advance a stage or multiple stages, the ants, pheromones and nests lists are all updated, showing ants moving around the simulation, interacting with food, the nest, and laying down pheromones. In this example, we can see a representation of Simulation 1. The simulation has been advanced by a few stages, and the ants are exploring the world looking for food. While ants are just exploring, they choose a neighbouring cell to move to at random. The image on the screen shows all of the neighbouring cells for the worker ant at 4-2. If we select Advanced Stage again, the ant chooses a random neighbouring cell to move to, and in this example, the ant has found food at 3-1. In the next stage, the ant then picks up a random amount of food, up to its carrying capacity of 30 units. It then makes its way back to the nest using a diagonal zigzag pattern, firstly moving a row towards the nest and then a column towards the nest. As it's moving back towards the nest, it deposits pheromones into the cells it is travelling through, making a trail for other ants to follow to the food source. On returning to the nest, the ant deposits the food it is carrying and then goes back out to search for more food again. With pheromones deposited in the cells, the movement of worker ants changes. Rather than moving randomly, the workers now follow a pheromone trail taking them straight back to the food source. At each stage, a worker ant looks at the neighbouring cells to find out which one contains the strongest pheromone and moves to that cell. When the stage is advanced, the nest also updates. At each stage, food is consumed by the ants belonging to a particular nest. 10 units of food are consumed by the queen and 2 units are consumed by each worker ant. Running out of food will eventually kill all of the ants belonging to the nest. At each stage, some of the ants belonging to the nest may also be culled, depending on the ratio of the number of ants, to the amount of food available in the nest. This is representing ants dying in real life as either the food level has got too low or the nest had become overpopulated. It's worth noting that in version 2 of the code, AQA updated the variable used in this process to ants in nest count, which is not an entirely accurate description. Worker ants belonging to a nest count would be a better name, as the code counts if workers belong to a nest, but does not check their actual location. Ants to be culled are selected at random, which means that a queen can also be culled. The final aspect of the advanced stage in the nest class, however, spawns new ants into the simulation. Each queen has a 50% chance of spawning a new ant once per stage. That new ant has a 2% chance of being another queen or a 98% chance of being a new worker ant. We hope that you found this resource useful and wish you good luck in your Paper 1 exam in the summer of 2026.